So I'd like to show you what happens when you do inequalities. Inequalities, if you'll remember, require shading. All right. Now, we talked about that in one-dimensional number line stuff where we would draw arrows. Remember when we would do closed circles and open circles? Remember that back in the day? We would do closed circles and open circles, and then we would draw arrows left and right. Well, that's one-dimensional number line stuff. Now we're dealing with two-dimensional. So same idea, but instead of open circle, we have a closed circle. In the same idea of a closed dot, we would have a solid line. Okay, and in this example, obviously, they both are solid lines. And that's because of the equal to part. Equal to part that you see in both of those examples. They say y is less than or equal to, y is greater than or equal to. If it's an open circle, which we'll get to in other examples, that is a dotted line. That does not happen in this example. Both of them have the equal to. Now you can see that I've drawn out the blue and the red, and I've also put little arrows. Now, why did I do that? Well, when you have y by itself, you can use the idea of greater than or less than. So with the red one, you can see that it says less than or equal to. So you see that I drew an arrow down. I'm shading below that line. I'm shading all the y values below that line. If you shaded all the y values below that line, you would get this section over here. Well, then what about for the blue one? It's a greater than or equal to, right? So that would be shading above. So you can see that I drew that little arrow right there. And if you shade above the blue line, so where is the solution to the system? The solution to the system is this part right here. It's where the purple, and I'll try to be nice and gentle here, the purple and the black were together to get at the same time. That's the green section right there. So above the blue line and below the red line. So the solution is that green section plus the boundaries. The lines, the blue line and the red line are actually part of that solution. Okay, let's move on to a different example. Hopefully I speed this up. So now that you understand the dotted line, solid line. So I graphed these. The top one, the blue one, is the dotted version. You can see I did like a dashed line instead of a solid line. I know that it shades below because it's less than, right? The other one is greater than or equal to, so it shades above. Now, the only reason you could say above and below is because these are in slope-intercept form. If we put them in a different form, I could really trick you with that, so we might have to talk about how do I really tell. The reality is you would want to use a point and test it. So my favorite point to use is 0, 0. I actually plug it in and see what happens. If you get a true statement, the red one, if you plug it into the red one, 0 is less than or equal to 0 plus 4, you definitely get a true statement. That means that the shaded part of the red one is below, which makes sense because that's where 0, 0 is at. Okay, all this stuff below. Okay, well then if you go to the blue one and you plugged in 0, 0, I'm not saying you have to do this for every one. I'm just showing you that if you weren't easily able to tell, you could plug in a coordinate. Okay, and that would give me 0 is less than -2. That is a false statement, so that does not work. In other words, 0, 0 is not on the correct so we would want to shade below the blue line. While shading below blue line gets me this. Obviously, you can see that it missed 0, 0, the orange part. Okay, so where's the overall answer to this question? Maybe I should clear that out and show you a little bit better. The overall answer to the question would be, why did I do that? Let's go to here. Would be this part right here and this part right here, and then everything out here. But so notice it follows the red boundary on the top, and once it gets to that intersection point right there, then it switches to the blue boundary. Question 3. So on the first one, we're dealing with a solid line, and it's shaded below. So 2x plus 1, that's pretty easy to see. You got plus 1. All right, so I don't know if I can quickly, do something here. Plus 1 and 2 is a slope, and we want a solid line, something like this, and we want shaded below that, okay? And then, of course, we're coming along with the other one. You can see that I put it in the other form. Y is greater than 2x plus 4 1/4. So I'm coming up here to 4 1/4. Same slope, so it's going to be like that, but it's going to be a dotted line. So they're parallel, and shading greater than would go up. Okay, so they're parallel lines, one shading below and one shading above. Well, guess what that means? They never, ever, ever, ever cross. The answer to the question was no solution. Now, this is a pretty bad fake answer right here, letter C, because as you can see, they go in opposite directions. So that wouldn't really make sense. When would you end up with letter A? You would end up with letter A if the signs were reversed. If they were flipped around the other way, and you were shading below the dotted line and above the solid line, then you would have ended up with answer A. So that was a possibility, but they ended up going in opposite directions. Okay, moving on to question 4. Try to hurry up here. Okay, so horizontal dotted going up. So the first one is a horizontal line, and it's dotted, of course, because it's greater, and it's shaded above. So we definitely want something that's shading above. That would be a bad choice because we're shading below a solid line, and this one is also out because you're shading below a dotted line. So B and D are bad fake answers. But what about this other part, the absolute value function? I reminded you right here that the absolute value function looks like the purple one, right? It's basically got a V shape to it with slopes of 1 and negative 1. The fact that there is a positive 1 in front of it causes it to open up, which we'll see differently in the next example. So I made a table, plugged in a couple of values, 0, 1, and 2, and when you plug them into this and subtract, then take the absolute value, you get 1, 0, and 1. That's the orange dots that I kind of threw on the graph here. And because this is not equal to, we have a dashed V going like this, a dashed V. Okay, and because it's less than, we're shading below the V. Okay, so outside the V. So we want above the horizontal dotted line and outside the V. That would be that one right there, because you're going down below the V, right? But you're also going up above the horizontal line, and that puts these little triangular shapes. Yes, they are infinite in size, so they're not exactly triangles, and there's 2 of them. Okay, apologize for going a little bit longer. I got one more example, and then we're done for this section here. The horizontal dotted going up. So we got horizontal not equal to, dotted because it's and going up. So at -3, those all. So this one's a bad answer because it's got a solid line instead of a dotted line. Now the other one is an absolute value function, and I made a little chart here, right? Plug my 1, 2, 3 in, and you plug it in. You subtract, you take the absolute value, and then after that you multiply by -1, and it ended up giving me these 3 values. So 1, -1. Don't like this, but I noticed that all of the scales are 2. So 1, -1. I'm going to have to actually zoom in for this. But 1, -1 is actually sitting right there. And 2 zeros sitting right there. And 3, -1 is sitting right there. So that's a little bit nasty. Didn't really like that one. And let's see here. Let's go back and see if I can finish this one out. So it does have to move to the right. And let's see. So we don't have to do with that one or that one. So we're really looking at B and C. And let's see here. Which one is solid shading down? Solid shading down. They're both solid. Shading down would be this one, right? Ooh, no. Oh, yeah, I got tricked up there. Solid shading down would be this one. Yeah, there's your answer right there. So the V shaded down, but the dotted line shaded up. Okay, sorry for the extra time there.